In this video, I'll talk about a second application of the normal distribution. Adults' men's heights are normally distributed with mean 70 inches and standard deviation 2.5 inches. Find the 90th percentile of the distribution. So for this problem, the area is given. So I have a bell curve, and I'm told that the area to the left of a certain mark is 90%. Notice that I draw the mark to the right of the hump because I have an area to the left that's more than 50%. So 50% of the area lies to the left of the center here. So if it's going to be 90% to the left, it's got to be clearly to the right of that. And the basic question is, what is the value of x, the height, that matches this area? So rather than having a coordinate and finding the area, this time the input is the area and the output is going to be the coordinate. Now there's a couple ways that this can be done. First way, let's use the table to get the answer. For the 90th percentile, I do not use 0.90 over here with the numbers on the edges. The numbers on the edges correspond to an x-coordinate. The numbers in the middle correspond to areas. And so I need to go looking for 0.90 somewhere in the table. And as you can see over here, 0.90 is approximately over here. You don't get 0.90000 exactly, but 1.28 looks like it's pretty close, and 1.29 is a little bit too large. So the coordinate that goes with it is going to be 1.28 something. And just by judging the magnitudes of these differences, this one's 0.00027 off. This one's 0.00147 off. You can probably see that's going to be closer to 1.28 than 1.29. So we can probably guess it's going to be 1.281, 1.282, somewhere in that range. And it's possible to actually interpolate between these two to get a reasonable guess as to what that third decimal place would be. So looking at this, it appears that indeed 1.28 is going to be the coordinate to go along with this area. That's using the table. Let me show you how to do this with Excel. The command in Excel would be norm .s.dist, .inv of 0.9, and that's the command that works in Excel 2010 using the dots. And when I hit enter, indeed I get 1.28, and of course because of the technology, I'm able to get more decimal places than that. Another thing that I could type would be norm s.inv without the dots. This command works in Excel 2007 and earlier. With the dots is Excel 2010, and that gives me again the same answer, 1.28155. That's using Excel. Let's now show you how to do this with a calculator. On the calculator, the command goes second distribution, and then inv norm, and then I type in 0.9, and I get my answer, 1.28155. Okay, so clearly the answer is not 1.28 inches. That's the number of standard units. That corresponds to 1.28 standard units, standard deviations above average. So to get the answer, what I need to do is take that previous number, multiply it by 2.5, and then add the mean. This number means 1.28 standard deviations above average, not inches. So to convert that to inches, I multiply it by the size of the standard deviation, and then add to inches to get 73.2 inches. So let me write that out here. The z-coordinate is 1.28. And I get that off the table, off Excel, or off the calculator. So the x-coordinate, when I convert to from standard units to inches, is equal to mu plus sigma times z. So 70 plus 1.28 times 2.5, and that works out to be 73.2 inches. So this problem illustrates how to do a percentile problem using the normal distribution.